I don't know if you did.
Which, come on. That's the one I want you to see. Okay. Now you should see the presentation. I think it was showing the wrong screen at first.
Yeah.
Yep, very good. Let's just see. All right, it's about 10 folks on right now. Just wait 1 second, since it just chimed in my ear that we hit 1 o'clock.
Yep.
Okay, we go ahead. Hopefully folks will roll in. There's a little bit of intro here in the beginning in any case. So welcome everyone. I'm John Bynum. I'll be chairing the session. Hopefully you can see my screen there. And then we have Paul Walsh from CIM. And I won't read the title to you, but there it is. So he'll get to the presentation here shortly. Just a couple items before we get started. Introduction, housekeeping, and events. Note on a couple of upcoming events, and then I'll hand it over to Paul, so it'll give him plenty of time to first presentation and questions at the end. So please use the questions tab to ask any questions related to the presentation. We have a survey and also a poll that will pop up. The poll will come up automatically, so I don't think you need to do anything for that. But the survey, please make sure you answer that. Give us some feedback. You can do it now, or I think it comes in the email afterwards if you don't get a chance to do it during the presentation. You can also use the chat function. If you have any difficulties, drop an email to the address listed there, secretary@ashraeireland.org. There will be handouts available in the handouts tab and also on our website later. So, oh, no, that's it. Okay. Sorry, I thought there was one more. Somehow I think it's hidden the slide on me, actually, about events. Apologies. Let me just pull this up. It was not supposed to be hidden there. Okay. Apologies for that. So a couple of upcoming events. There's the general meeting, which is tentatively scheduled for 21st of June. So that'll be hybrid, local, and online. So if you're not able to come to wherever the presenters are, the main presenters are, you can join online. The ASHRAE president, Mike Schwedler, is visiting Dublin for a couple days in May. So there's some events and I believe a presentation associated during his visit. And a couple conferences upcoming, the ASHRAE annual conference in Toronto, 25th through 29th of June. Conor Murray will be leading the Irish delegation. So if you are joining, please reach out and let us know. So we're going to coordinate our efforts and make sure we attend all the items of most interest to the chapter. And then finally, on the list here, ASHRAE Europe CRC. That's a sort of an organizational meeting. It's for the region. It's 8th through 11th of September in Madrid. And there's one other one in September, which I forgot to put on here, which is the Building Performance Analysis Conference and SimBuild, which will be in Chicago. So apologies for not listing that there. So without any further ado, I will hand it over to Paul.
Thank you, John. I'm going to try and share my screen now and see if that works. Let me know if it does. You guys see that?
Good. Mm-hmm.
Perfect. So thank you, John, and thank you to the ASHRAE members for affording us this opportunity to give you guys, I suppose, an overview or some lessons learned of what we see, you know, in the sites that we're deployed on around the BMS Alarm Fatigue syndrome that we've coined it, and some of the risks and the rewards that can be delivered through the data analysis piece. So let me try and flick on. Yeah, so look, a bit about myself. I have an engineering degree 25 years ago now, so it's quite archaic. But I spent all my working life in the high-tech manufacturing sites, and in the last 12 years, I suppose I've been involved primarily in the energy and the sustainability functions in each of those roles I've been in. So I have, you know, a good bit of experience in what works from an energy efficiency implementation and execution perspective, and also I've first-hand experience of this BMS alarm fatigue that we're going to talk about today. A bit about CIM. What CIM have done is we've built a software platform that enables people to operate their large, complex manufacturing sites at their peak performance, and that delivers an incredible economic but also an environmental benefit to the clients we serve. The company itself is probably about 5 years old. It started officially in 2014, but it was only I suppose incorporated in about 2017. My brother David set it up. He went to Australia and he saw a gap in the market around how companies were not using system level data to operate to better operate how their plant and equipment was running. Typically companies were using energy meters, CTs, to try and diagnose when there might be issues with plant and equipment. And David then built the software in conjunction with a guy called Anton Mascaboy, and we now have 60 employees split between EMEA and Australia. We have it on a large cross-section of buildings, which gives us a good understanding of this BMS alarm fatigue syndrome, because it doesn't just happen in the high-tech manufacturing space. Happens in commercial, it happens in airport assets, it happens in banks. Every type of an asset we're on, we see this as a common thread or a common pain point, if you like. We're lucky enough now to have a global presence. We're operating in the US, in Europe, and in Australia, and now in China, actually, in the last couple of weeks. And as I said, we have that multiple sector experience. So it is, I suppose, it does qualify us in some way to talk a bit about this and to share some key learnings. These are some of the clients that we help, specifically in EMEA, specifically in the high-tech manufacturing site. A lot of them have similar pain points around having huge, complex sites, having legacy systems, having a myriad of old and new technologies, and struggling, I suppose, to manage all that. And then, as I say, how to decipher what is a genuine BMS issue or genuine optimization issue versus some potential white noise. But we're adding a lot of value for clients like this. So again, we're lucky to be doing so. And what the agenda for today is really is just to get, we undertook a piece of research, and I'm going to talk a bit about that. And then I suppose how we feel ways to avoid this BMS alarm fatigue syndrome. I'm going to touch on kind of tips and tricks around HVAC optimization, talk a bit about some case studies, and then leave you guys with some key takeaways. And the plan is to talk maybe for 25 minutes, maybe 30 minutes, and happy to take Q&A. So please, as per John's suggestion there, please populate as many Q&As as you feel I can adequately address, and I'd love to get your comments or feedback on the how meaningful this presentation was to you guys. So please, I'm thick-skinned, so please, feedback is greatly appreciated. So let's dive right in. I suppose the undertaking we CIM did was we asked 100 facility managers that were specifically in the high-tech manufacturing space their thoughts on energy. Right, we made it kind of nice and broad like that, and then we began to ask some questions around BMS alarms and how they feel their facilities were operating. So it was very much to try and tease out some of the pain points that they were experiencing in their day-to-day life, and a lot of it. Some of the stats that jumped out to us, excuse me, were interesting. We're saying that in terms of the energy consumption, HVAC, and when I say HVAC, just to tease that out a small bit, I'm referring there to like all the boilers, chillers, air handling units, cooling towers, primary, secondary pumps, everything that hangs off that system, if you like. It doesn't include things like production equipment, or data centers or anything like that that are outside of that HVAC realm on sites. But interesting, 34% is a really big number. If you think about the climate in Ireland and in the UK, where you can pull in a lot of outside air to cool facilities, but yet still 34% of these large manufacturing sites' energy was being consumed primarily by chilling either water or air. So it was a really interesting statistic for us. And interesting, the second point that came out on that from the survey was that there's a lot of capital constraints, and this probably aligns, with on the back of COVID, where sites are conscious about spending any capital on sites that are partially occupied, and more so in the commercial real estate sector than in the high-tech manufacturing space. But the availability of capex is becoming now a problem. Another key point that jumped out was the sites are not using data. Really, they're not using data to inform how to go after the opportunities that are presenting themselves on their HVAC systems, which I thought was a staggering statistic. And the next one then is, so sites mentioned that even if they could use the data, a lot of the sites are deficient in the number of data points they're either collecting or ingesting or doing analytics on. So a lot of them are flying blind in terms of instrumentation in the field, and they can't, if they wanted to, even deploy the analytics solution that a lot of companies offer. And then in terms of the CO2 emissions, a lot of companies now are signing up for aggressive CO2 reduction targets, probably being enforced from the parent companies, and the sites in Ireland are now figuring out how they're going to report out on their carbon emissions, and a lot of them are not doing that right now. They're depending on their utility providers to do that for them. And again, that struck us as interesting, because a lot of these sites are committing to carbon neutrality by 2025 or 2030 as an example. Another key issue that kind of came to the fore for us was around a lot of the sites are still in that reactive mode for HVAC maintenance, and that, I suppose, it might resonate with some of the attendees on the call today around that. The modus operandi of the facilities teams tend to be, when they get a phone call, they react to a chiller after stopping, or an air handling unit not working, or a VAV not providing thermal compliance in a space, and it's very much in that constant reactive mode and not being able to get out ahead of the challenges that the site faces on a day-to-day basis. And interestingly, around the leadership support, one of the things that we noticed was, or that came back very evidently in the survey, was that only 35% of the C-suite, or in the facility manager's perspective, would be the senior leadership team. They didn't realize that HVAC was such a significant energy user. A lot of times the site leadership teams are driving CIPs around efficiency of the operating or the production equipment, and sometimes the opportunity to optimize HVAC goes unnoticed, if you like, and that came to the fore in the survey. And sorry, one of the points I should have mentioned before I dived into the survey was on the second slide I showed. There's a QR code, and if anybody wants to scan that, it gives them a full copy of the research and the key findings. What I just showed you here is a summary, but anyone that would like to, please feel free and dive in and get a copy of that. So one of the other things we're going to do here, if it's okay with everyone, is we're going to try and involve the audience, and one of the things is an audience poll. So we're going to ask if the participants on the call here today, if you actually know what is the largest energy consumer on your site, and the options are heating, air conditioning, and again on the hot water side, on the air side, steam, high temperature hot water generation, compressed air, chiller plant or refrigeration, and then if any others are sometimes sites can have nitrogen generation, or production equipment can be a big significant energy user. So we'll just leave that open for another a second or two, and we can close it off then. Right, maybe just see if it does it. Ah, wow, interesting. So yeah, that aligns quite closely to what we saw in the survey, where this is actually the results of it, where the biggest single energy cost, or the biggest energy user, if you like, was the validated heating, and that's around, I suppose, providing compliance or thermal conditions to big clean rooms or validated spaces, GMP type environments, and trying to ensure that, specifically even on humidification loops and positive pressurization areas, that the biggest energy consumption is in that space. So that aligns very much so with what we've seen in the survey. So thank you for that participation. Sorry, no, don't want that. The next one. Yeah, so the next one is another question. How would you describe your HVAC maintenance strategy? Would reactive, predictive, or preventative? Again, it'd be great to get some feedback from people on the call on that. And we just give it another 5 seconds, Aoife, and then we can close it off, please. Perfect. Right. So interestingly, a lot of sites that are on the call, or a lot of participants that are on the call, view their maintenance strategies as reactive. And that's a really interesting finding as well. And it aligns exactly with what we've seen. Where I suppose what it would show to us is, in spite of the impact of the net zero commitments, the senior leadership teams are still seeing the fact that there's not a link between how we could proactively maintain our HVAC systems and how that would deliver a CO2 emission. So that's really, really interesting. Okay, thank you. And now to jump in, I suppose, to the bit of the presentation that it's kind of the meat on the bone, if you like, around the BMS alarm fatigue. And interestingly, what came out of the research is that 1 in 3 facility managers that we surveyed believe that their BMS wasn't correctly commissioned day one, which is a kind of a staggering statistic, really. But if you think about how buildings are handed over, they're normally, the commissioning piece is normally done in the 11th hour, and it's normally under immense time pressure to get the project handed over. So it's probably no surprise that this is coming to the fore. And a lot of times the BMS vendor is the person or the company that's commissioning the BMS, and a lot of times that checking their own homework philosophy doesn't necessarily result always in a correctly commissioned system. So that statistic really jumped out at us. And the second one that jumped out at us was that the number of BMS alarms, and the number 12.5, I suppose, is the average alarm that the BMS is producing on a daily basis. But it was, a lot of sites have put in 0 into this, but what we saw was as many as, some of the sites are reporting as many as 30. Now, if you think about the, I suppose, the role of the facility manager, he or she is struggling to deal with the day-to-day operational stuff, yet alone try and identify, of the 30 alarms that are coming in, which ones are, ones that they have to go after, and which ones are kind of low value alarms, or essentially what we call white noise. And I suppose the next question then was around, how useful are is the BMS at identifying HVAC issues? And 58% told us that their BMS was only somewhat helpful. Excuse me. And a further 20% telling us that it was neither too helpful or not helpful at all. So again, that kind of jumped out to us that the key to controlling maintenance costs is development of a more preventative maintenance strategy based on data. And that kind of just jumped out of the survey we did as well. And I suppose, interestingly, the poor BMS commissioning we found is hampering rather than helping the high-tech manufacturing understand and control their HVAC systems. So that was an interesting one. And then we had the very Reverend Conor Murray on one of our panelists recently. And he was aligning with this perfectly, right? And Conor is a very experienced man in the HVAC optimization space, and specifically in the validated spaces. And he flagged the concern around the accuracy and the relevancy of data, and to allow that type of foundation level, I suppose, data to be available to enable BMSs to be intelligent enough to identify what are the key priorities for sites to go after, and what essentially are white noise. And I suppose then that would allow sites to start benchmarking and sharing lessons learned between sister sites if they're part of a large group, or even amongst peers within the Irish sector, provided the data can be anonymized. The next question, so for the audience, is how well is data collected and analyzed in your facility? And I suppose there's kind of bands here. It's good at data collection and analysis, good at analysis, but not great at collecting data, poor at both data collection and data analysis, and then good at collecting data, but poor at analysis. So a couple of different options there for the group, if you could share your thoughts. And again, this is all anonymous. We're not going to be quite Chatham House rules, but we're not going to be reporting anyone out if the findings aren't what we want them to be. So give another couple of seconds there, Aoife, please, and you can just end that one. All right, it's kind of a more level playing field here now. So poor at both collecting and analyzing data was probably the forerunner. Good at collecting data and analysis. It's interesting, a third. That's really interesting. Good at analysis but not collecting data was about 18%, and good at collecting but not at analysis about another 18%. So that's really interesting findings as well, and just see how that collates with. Yes, so interestingly, the majority of the people we surveyed as well believe that their site was good at data collection and analysis, which is really interesting. Okay, the next slide then speaks to oh yeah. So again, this is going back again to the core subject of the presentation, which speaks to the number of BMS alarms receiving no action. So again, this was varying between the low level of alarms, and some sites were getting about 30 a day, and what percentage of those were being actioned. And interestingly, like 2/3 of all the respondents do get BMS alarms, but only 1/3 of them are reacting to them, which is really interesting. And again, what that jumped out to us is that, or what the key finding from our perspective was that a lot of the issues that the BMS alarm is alarming on are low and no value tasks. And even if I'm to reflect on some of the sites that I worked in throughout my career, when the facility technicians were not sitting in front of the BMS looking to see what alarms were being flagged and whether they should be actioned or not, outside of working hours, that job typically went to a security guard, and he or she, in most sites, the BMS would trigger, say, a critical 1 alarm, which might be a chiller or a stopped or something like that. But all other type of alarms, the security people had the ability to, silence the alarms or dismiss it. So again, that kind of jumped out to me and really resonated with me here around, the fact that a lot of alarms are being flagged, but there's no action being executed on the back of them. And most of the BMSs that we see on the sites that we're working on are not able to differentiate between the different priorities of the alarms. Now, notwithstanding the fact that the BMS will know when it's a critical alarm and a piece of plant and equipment has stopped, but in terms of identifying opportunities to optimize the plant and equipment in advance of it stopping, to allow energy savings or operational improvements to be delivered on that plant and equipment. BMS that are just not programmed that way, and I suppose typically in our experience, the BMS vendors or the BMS companies are not tasked with that scope. Their primary function is to maintain conditions, and whereas doing so at the most energy efficient way is not necessarily part of their brief. So that was another interesting statistic. And then I suppose we have here just, if you like, tips and tricks on how to deliver HVAC efficiency. And again, it talks about the importance of the maintenance regimes, moving from the schedule-based maintenance, which is changing filters and belts and things like that on a frequency basis instead of a condition basis. And that's where we need to get this industry away from. We need to move away from schedule to conditions, and that using data to do that is immensely powerful. The operational is an interesting one in that a lot of plant and equipment is left running 24/7 just to try and maintain conditions in the space, and it mightn't always be required. So we got to back away from that excessive operation, and there are significant opportunities to be achieved in that space. It's the famous low-hanging fruit that everyone refers to. In our experience, excessive operation is that low-hanging fruit. Overriding control set points. Again, this is kind of people who are trying their best to fix an issue, and they'll manually override some set points or put plant and equipment into hand or into manual, and that prevents the BMS from being able to optimize or control things. And the next one is about physical installation, and this goes back to the design phase. And anytime engineers, like anyone has experience on the facility side, anytime those type of people can get talking to the designers is always a benefit, because when a piece of equipment is overspecified, it's very, very hard from an operational excellence perspective to do anything with that, because it's just not fit for purpose. It's either grossly oversized, or else it's undersized, or it's just not fit for purpose. So the energy efficiency at design stage is key, and SEI do a lot of great work around this XC program, which is excellence in energy efficiency and design. And there is SEI's statistic actually is that 80% of the life cycle energy consumption of a piece of equipment can be saved at the design stage if it's properly designed. So that's an immensely powerful one, and often gets unnoticed. The control algorithms, so again, making sure that they're operating correctly and suitable for the application, because sometimes it can be copy exact between sites, and if the site is located in a different geographic area where the climate is different, that obviously that control strategy won't work in Ireland or in the UK. And around analytics software, I suppose that can definitely help with the maintenance, as we mentioned, around moving from schedule to condition-based maintenance. It can definitely track and flag excessive operation and get that resolved really, really quickly. And then sometimes the empirical data set that a lot of these analytics platforms sit on is immense in terms of the amount of data points that we collate, and they can be used then to advise either a model or advise consultants on how to correctly size plant and equipment. So this is, I suppose, analytics will deliver, or using data will do a couple of things for you. It will prevent the BMS alarm issue becoming such a pain point. It will also improve the operational efficiency, which will give you a demand side energy reduction, but also in terms of future thinking or future proofing your site, it'll allow you to improve your capital planning. It'll allow you to prolong the plant and equipment life cycle, and it will really tick multiple boxes for sites that are struggling to get on top of their HVAC optimization. And we're fortunate enough to be working with the Johnson & Johnson organization, and Barry O'Sullivan, who used to be the Vice President of Manufacturing up until a month ago, he gave us a quote there around why they deployed Peak, and he was all about driving them, maximizing the efficiencies. J&J have a very significant CO2 reduction goal, and he sees this as being an integral tool in the toolbox to deliver against that in a cost-effective way. So we're lucky enough to be across 11 of the Johnson & Johnson sites globally at this stage now. And then I want to talk about some success stories, if you like, or some stories about how the BMS alarm didn't pick up issues that potentially would have become a problem for the site. And apologies, this is very graphy here, but on the left-hand side, it's showing, if you like, the green squiggle line here is the chill water valve on an air handling unit, on a coil in an air handling unit. And you can see it goes from modulating, albeit very, it's essentially hunting here, which is another problem, but it went from modulating up to maybe 100%, and it stayed at that 100% maximum cooling, or maximum valve position open, which is maximum cooling, for a sustained period of time, and it couldn't achieve the supply air temperature in the zone temperature in the space. And you could see then the temperature profile in the area. So it's trying to control to just over 20 degrees, 21.5, and the critical alarm point is at 24 degrees. It's up here. And what happens after 24 degrees is it's critical 1 alarm, and then the BMS essentially flags it as a red alert, and the fire brigade are called out. I know the maintenance or the facility team are called out. But what can happen then in an instance like that is if that area goes above that 24 degrees, it's potentially a non-compliance, and in an area where you're making validated, or in a validated area, it can result in quality getting involved and maybe production being stopped for a while. So the BMS was flagging level 1 and level 2 alarms according as temperature was increasing, but again, that opportunity to get out ahead of this issue was lost in the white noise that was BMS alarms. And ultimately, what the cause here was, there was a strainer that was feeding, that was right before the coil, and even though the valve was open 100%, the strainer was blocked, and the cold water, the chill water, couldn't make its way into the coil, so it couldn't achieve cooling, and the temperature was increasing incrementally. So what the analytics did in this instance was it detected that in a really short period of time, It assigned the action to the maintenance team and told them exactly what they needed to do to address this issue. And those guys went up and addressed it. And again, the issue was resolved without any compliance or any kind of impact to quality. So this was an immensely beneficial way of proving the value of data analytics over and above what BMS alarms do. Next one, this I suppose touches on the point raised previously around the manual overriding of set points, and in this instance you can see that we have, well, again, maybe you can't see it, but we have on the graph here, we have supply air fans that are being locked at a specific hertz, even though they have VSDs installed, and that's essentially negating the job that the VSD does. So both of them locked at are fixed at a manual set point, and for no reason that we could understand anyway. So once the software picked it up, we were able to work with the on-site team to get those fans turned back into auto. And you can see from where they went from 45 hertz to a situation where they were modulating depending on load in the field. And again, that's what we see is analytics can provide resolution to a large energy consuming site by a series of small wins. Instead of one massive opportunity, it tends to be resolution by 1,000 small wins. And this is an example of one. I think the net saving here was about 12.5 kilowatts. So again, it's not huge in the overall scheme of things, but enough 12.5 kilowatts does equate to a significant savings year on year for a solution that is an OPEX only type execution. This one is about it speaks, and again, this is just showing the energy consumption, if you like, before versus after. But what we noticed here was that there was an air handling unit that had a hot water loop that used to have to run 24/7 because it wasn't properly treated from a chemical corrosions perspective. So they had to keep the water moving. But what was happening, and we knew that to be the case, but and BMS was actually flagging that as a low-level alarm as well. But what was happening as well as that was that it was bringing on the air side, so the fans were coming on, and even though there was no heating requirement in the heat transfer required at the time, if you like. So again, this was around the operational issues where plant and equipment is running unnecessarily. And the software then flagged that, and we raised what we call it is an action, and we assigned it to the site team to resolve, and they were able to resolve it in a matter of days. And you can then see very much before versus after on that graph in terms of energy consumption, and that's at main meter level. So there's been a significant savings on, I think it was around 78,000 kilowatt hours per year. The next one here is just about instrumentation, and I suppose it's a key one for us. The BMS alarms are in a lot of instances identifying issues with instrumentation in the field. So a temperature probe not reading correctly, a static air pressure sensor not reading correctly, outside weather stations gone offline. All these type of I suppose, if you like, low-level alarms, but they have a massive knock-on effect to large plant and equipment upstream. And here's an example of one. This is a static pressure set point, a static pressure sensor in the field here, and it was reading anywhere between 500 and 620 pascals, but it became faulty at this point here, and it started reading a much lower pressure in the duct. And as you can see, the BMS then reacted, and it brought on the supplier fan from a 50% speed, which was running on the BSD, up to 100%. Now, the reason it's turning on and off is the night mode and the weekend mode was still operating. But you see, when it did come on, it was still running 100%. And even though it wasn't making any difference to the supplier pressure in the duct. So the software here in this instance identified that the static air pressure sensor has gone faulty, and that needed to be changed. And it was like 200 euros to fix that. And as a result of that instrument being changed in the field, you now have a 37 kilowatt supplier fan that has essentially run at, it's now running at maybe 10 kilowatts because it's able to back off that 50%. So again, that was a really significant, and on the right here, it shows the energy consumption before versus after. So it's a significant win there around the instrumentation. That was a key point we've noticed. Oh, sorry, that's in there twice. Sorry about that. Yeah, and I suppose the key point I'd like to touch on now is around the gap, I suppose, between what data analytics can provide, or data analytics platform can provide, versus in terms of identified savings versus what can be realized. And I suppose in our experience, you know, analytics will do a couple of things for you. As I mentioned, it'll reduce that white noise coming from the BMS alarms, and it'll prioritize what the facilities teams on site should be going after. But if the facilities haven't been empowered with the ability to close them out, then nothing still gets done. So it's very little benefit add to or value add to the site. So I suppose what we see as being the secret sauce is really this simple and easy to use resolution process that enables the facility technicians to bridge the gap between identified and realized savings. And most facility technicians that we work with haven't the time, or they haven't the technical prowess to dive into BMSs and diagnose what's going on. It's normally a time thing. They probably have the technical capabilities, but they don't have the bandwidth to do it. So by using software to identify opportunities, and then by putting them into an easy kind of follow, intuitive, very simple methodology around closing those out, there's a much higher probability of that engagement with the key stakeholder in this instance, which is a facility technician, to allow him or her to get the issues resolved. So, and we have seen that time and time again, that unless you can make it a joyful experience for the end user, as I say, the challenge is that nothing gets realized. And I suppose what I'd like to do now is maybe finish on a human story, if you like, because I think this is important, because ultimately humans underpin any kind of a successful optimization project, whether it's, you know, a BMS upgrade or a data analytics execution. Unless we have people to help us execute that at the coalface, nothing gets done. So this is John. He's a facility manager in a high-tech manufacturing site. And you can see in the photograph here, he has lots of different systems on his sites, right? He has a BMS, he has a CHP, he has thermal oxidizers, wastewater treatment plants, and maybe people on the call can identify with this, but typically there's a PC for each of those systems, and everyone has got, you know, logins to those different systems. And I suppose John in this instance is dealing with a plethora of platforms. A lot of these systems are gone, you know, they're legacy systems now, so they have no interconnectivity between each other. And again, that's just compounding, I suppose, him and his level of frustration by the lack of transparency that he's seeing. He's hugely dependent on third parties or on contractors. And there's an element, I suppose, from John's perspective, is that he's feeling out of control. And again, if you're to flip it onto how John's day typically rolls, is he's constantly in that reactive mode. The phone is ringing, people are giving out saying it's too hot or too cold. He's juggling priorities, and it just doesn't get the time to sit down and either review BMS screens or think strategically. So, and again, the challenge for John is that there is a perfect storm going on here, right? That he is experiencing increasing energy prices, which have ratcheted up almost 75% year on year, if you think about it, specifically in the electrical price in Ireland. He's also getting hammered with CO2 reduction targets that he's got to hit. And then that's being compounded by the fact that he's not getting any new resources. So he's doing it with a very, very limited crew. And yet he has to deliver these, what seems to be diametrically opposing objectives. So there's a lot of pressure on him, and that's the perfect storm analogy that we like to talk about, because it's a very, very difficult job nowadays. And I suppose trying to get it back to the human element and how data analytics can help a guy like John. And in our experience, it helps prevent that white noise. So anything the BMS is flagging is essentially analytics will be provided on top of that to identify what are the key ones to go after and what ones can be essentially ignored or can be deprioritized. It ensures people like John then that any HVAC optimization tasks that are being executed are high value tasks. And that might mean a CO2 reduction or an energy reduction or a compliance alignment or a safety find. Again, we see a lot of those on the analytics, and also prevents then what the facility managers in high-tech manufacturing sites absolutely hate, which is prevents unplanned downtime. A chiller falling over, or a belt on an AHU slipping or failing, or cooling towers tripping out, or whatever that issue is. The analytics, the data can often be indicating those type of failures. So allowing that type of allowing John and his team to get out ahead of those type of issues is immensely powerful. And as I said, it's nice to stitch it up with a human story at the end. And I think that concludes my presentation. Thank you for your time, and I'd love to get some, let's say, questions or comments, feedback, whatever. John, over to you. Next steps.
Sure. Yeah. Thank you very much, Paul. So we have 2 questions in the questions window there. If you have any others, please do drop them in. So we'll just go with the first one there. So question is, you spoke about the industry and corporate net zero targets with the lack of C-level and CapEx support too. Then we see support from government in the residential sector with schemes like retrofit. Should government do more for industry?
Yeah, so that's a really interesting point, actually, because we were just doing some analysis on that in the office in the last couple of weeks or so. But what we found, what we kind of came to the conclusion is that, like, the domestic retrofit scheme is definitely a good start by the government, but we feel that trying to get 500,000 homeowners to spend maybe between 20 and 25,000 euros on their houses to get them, to get I think it's a 4 million tons of CO2 reduced by between now and 2030, and it's going to cost the government 8 billion to incentivize that or subsidize that, is not the best value, in our opinion, for deploying taxpayers' money. If you think about it, in the high-tech manufacturing space, or even in the high-value corporate space, even in the SEAI lean membership list, there's probably 200 companies, right, that are on that, and they're probably responsible for the majority of emissions from the industrial sector in Ireland. And it's a much smaller cohort of stakeholders. It's only 200 people, or 200 companies essentially, and they have a much more burning need to become operationally more efficient than, if you think about it, than a house. In that the cost of energy is going up so much that they need to drive that level of efficiency down to, or need to improve their level of efficiency to stay competitive in Ireland. So we're kind of imploring the government that they would develop a similar scheme in Ireland that would not only encourage companies to become more energy efficient year on year, but it would legislate for that and to put in binding measures that would, hold them accountable if they're not. But also, that's kind of a carrot and stick approach, but also to help them on that journey to deploy proven solutions that will help them become carbon neutral by 2030. And there's a much better value for taxpayer monies by focusing on a small cohort of people than trying to go after 500,000, in our opinion. Long-winded answer there, Joe.
No, all good. No, that's a good one. So next question and there's the only other question in the questions window there. So please fire away, folks. It says, otherwise you're gonna have to go with my questions. So here we have, is analytics going to end up firing more alarms at me, or how is that managed?
Analytics is not going to end up firing more alarms at you. No, analytics is going to help provide a level of intelligence to the BMS data that will develop actionable insights that are prioritized. So what analytics will do for that person who asked the question is it will help transform how they can operate their HVAC plant and equipment more efficiently. And it will eliminate the alarms that are a kind of a white noise or a nuisance, if you like, right now. Sorry, just let me caveat that point. They're not all nuisances, but there are a couple of diamonds in the rough. And what analytics will do is it will bring those to the fore, and it will not only will it tell you what's wrong, but good analytics platforms like CIMs will also recommend a solution. So it'll tell the technicians exactly what they need to do. Go up and change actuator A on AHU 07. That's causing the issue. And when he or she does that, then the issue goes away. So it's very insightful, very very time efficient, and very resource efficient.
Okay, very good. So one more question came in here. It's, I think, a little sort of related to that one. The application that was displayed, does it do the fault detection and diagnostics part as well, or does it aggregate alarms from a number of BMS systems?
No, so it does. It takes our particular analytics platform takes system level data. So we take valve positions, VSD speeds, outside air temperature. We take all the analog inputs, analog outputs, all the digital inputs, digital outputs, and the set points, and we essentially deploy fault detection diagnostics rules across that data set. So we don't even look at what the BMS is alarming on. We use the system level data to generate our own, what we call peak actions. And then we work with the on-site facilities team to get those actions resolved. So we don't collate data from BMS alarms. We look down at the granular level, system level data, and use that to inform our models on how to best identify what needs to be addressed.
Okay, very good. So this was coming from myself. Folks, please feel free to drop more questions in. How often do you suggest the installation of new equipment or sensors to enable your platform? And if you ever do, what's the level of investment qualitatively that you typically see for that?
So your question is, do we recommend additional instrumentation? Is it to allow plant? Yeah. So that's a really good question. Sometimes we go to sites and they would have significant data gaps, where they might just have a temperature sensor in a large open space, and there could be multiple air handling units trying to control to one temperature sensor, as an example. So we would, in that instance, our first cab off the rank with that client or clients like that is to try and optimize what they have. So just understanding the data set and then understanding how analytics can add, value at the first step or the first increment. What we would then do in that instance is we would say to clients, listen, if you were to put a static air pressure sensor in the ducts, we could then maybe control the VSDs a bit better. And we would start building fault detection diagnostics rules around those recommendations. So by recommending the client to install some instrumentation or sensors in and around the energy intensive plant and equipment, you can often get a very good return on investment. Because the default position, John, and it's an interesting point, because the default position is you get companies that say, listen, we want to become carbon neutral, or we want to improve our CO2 emissions. Let's rip out that chiller, or let's change that air handling unit. And that's a several €100,000 investment. And our counter argument is that the air handling unit itself might be fine. It might just need some low-level investment on instrumentation that will allow it to operate more efficiently based on load in the field. So that can be a very quick ROI for clients that are thinking of going down that are on that CO2 reduction journey.
Okay, very good. So one question just came in. Ricardo, you saved everyone from me posing the next one. Does the client write the FTD rules, or do you have a big FTD rules database where you have a number of building diagnostic rules that you can offer to a client, or is it a mix of both?
So we have our own library of rules. The software, as I said, we were looking to hire a very good software developer, and we built the software ourselves from the ground up. So we have as part of that, in parallel, we also built our own FTD library of rules. So it's about 3,000 rules now. And depending on the plant and equipment that a site has installed on it, we will deploy a specific set of rules against that data set. Now, there are some, the software we have has the ability for the client and for us to help them to write bespoke rules. So if a client has a very unique piece of HVAC plant and equipment that we haven't come across before, we can work with them to develop a fault detection diagnostic rule. We can get the data from that plant and equipment ingested, and then that rule will continuously monitor that data set, and it will flag when it begins to deviate outside of what it was originally commissioned or controlled to be. So 99% of the rules, John, are in a library that we have. A couple of them need to be bespoke, built.
I see. Okay. Yeah, this one's going to come from me. I've seen some meta studies of retro commissioning, which some of what you're describing is sort of in that direction, although your platform helps with persistence of the savings, if I put it in my own words. So I don't know if you've taken a look at that and you have an idea of what type of savings you generally see at initial implementation, and then how long does that persist, and what are the most common actions that your system puts forward?
So I suppose yeah, there's a couple of I suppose what we see initially is like when our analytics technology is implemented on a site, we tend to find a lot of operational improvements, and they're almost very quick wins. So and again, it's all about resolving those low and no cost opportunities. So excessive operational hours, pieces of plant and equipment in hand or in manual, instrumentation in the field not working. And what happens is when you address all those housekeeping type issues, you get a significant demand side reduction, because a lot of times plant and equipment is operating that way for the last X number of years, and no one has ever taken the time to do the analytics on it, because again, it's a time thing, right? They don't have the bandwidth to do so. So we definitely find that when we're deployed, normally in a matter of like anywhere between 3 to 6 months, we have a situation where we have reduced the demand side reduction, specifically on HVAC, by anywhere between 10 and maybe 20%, 25% on one side, and that's just on the HVAC load. So you get a very quick win, and what that has a couple of impacts in that it allows the on-site team to see the value in the analytics as a solution, but also it enables them to, and again, to your point, it ensures that those savings don't degrade. So a lot of sites get equipment optimized by an external consultant. He or she will come to site, they'll optimize the equipment, and they'll leave again, and very quickly those savings degrade. But the analytics, because it's intelligent, would prevent that from degrading over time. So I suppose that would be my primary answer to that question, John. I hope I did it justice.
No, it's all good. Yeah. So I don't see any other questions there. But so to your point about if you do retro commissioning, maybe you go consultants will go away and then come back, say every 3-5 years or something. How often do you find yourselves needing to repeat a similar cycle, if you do?
So interestingly, the way our execution model works is we don't ever need to have engineers on the ground. The biggest challenge we see with sites is that the data integration is the biggest piece, and that's where the way a data analytics solution like ours work is that we install a data acquisition device, and that acts as essentially a listening device, and it sends the data out to our cloud-based platform, and that the platform will run the analytics across it, and it will identify what exactly needs to be fixed. So us sending engineers to the site with a clipboard and a camera is of no value to us or to the client, because a lot of times we can diagnose exactly what's going on remotely, or the software will pick it up. The engineers being remote can, as I say, work with the guys who are at the coalface, because they have an immense tacit knowledge. They will know why plant and equipment is running in a particular way. There'll be a reason normally behind it, and sometimes they don't know, and then we can help them retro commission it, to use your term, which is exactly what we do. So yeah, that's kind of that one.
So I think we're almost at the end of the question period, but I had one more. Sorry, I just got a message. My network's slow, so hopefully y'all can still hear me. Your title is the risks and rewards that can be delivered with data. So I take it, I mean, your platform helps to reduce the risks and realize the rewards. But what are the primary risks that you still see outstanding even after application of a platform such as yours?
The risks of BMS Alarm, is it?
No, just general risks associated with data. So I think you were saying you utilize the data to realize these savings, but you have to enable it, etc. But what are the risks that are still out there utilizing the data?
I suppose the risks are it's an interesting question. The risks are really what we see is a lot of data in silos. As I said, you have a BMS, you could have an energy metering system, you could have CHP, you could have all these different data silos, a lot of them not talking. Sometimes you have proprietary systems, so you need to get the vendor to come back to access the data that, you know, that's on your site, which is a crazy system. So the biggest risk, if you like, is, in our opinion, that limited internet connectivity. By not being able to stitch all that data together, it hampers the efficacy of data analytics, because you're essentially you're flying blind. There's a lack of transparency, if you like, and we see that right across the sector. So you know what the reason, I suppose, one of the reasons the CIM team get out of bed in the morning is we feel that there's a lot of opportunity for us to make a significant impact to the CO2 emissions from the built environment, and specifically in the high-tech manufacturing space. And we feel that, you know, using data analytics is a very quick way to start realizing some of that. Like, if you think about it, when sites want to become carbon neutral, they'd say, okay, we've got to procure green energy, or we've got to put solar PV on our roof. Our argument is the other side, say the first thing you should do is to reduce the waste that is inherently happening on your site. And, you know, that can be anywhere between 10 and 20%. And you know, once all that waste is squeezed out, then maybe look at PPAs or on-site generation. But if you don't do that first, you're essentially baking the waste into the renewable piece. And we feel the BMS data represents an absolute treasure trove of opportunities for optimization of plant and equipment. And it's just not being properly mined right now. And that, in my opinion, John, is the biggest risk, that that industry doesn't wake up to this. And we're in a situation by 2030 where we don't meet our CO2 emissions as a country, then we're getting hit with these huge EU fines. And I suppose we're imploring to government and to large industry to, you know, to start this process. And it absolutely will be a seismic mind shift for them in terms of what they can achieve from it, and in a very short period of time.
All right. Well, Paul, thank you very, very much for the presentation and for all the questions. I just have a couple of announcements here in the last 3 or 4 minutes. I'm going to share my screen again here. Hopefully I give you the right, I think I've given you the wrong screen here. Let's see if I can get the right one. Okay, yeah. Well, do you see the slides, Paul, or do you see?
Yeah. Yeah.
Okay, all right, sorry. I wasn't obvious which one we were looking at there. All right, so just a couple of announcements. So please stay in touch. We're quite active. The chapter is active on the website, Twitter, LinkedIn, ASHRAE, and then YouTube channel where the videos from the presentations are posted. And then you can always subscribe to our mailing list so you get the announcement if you're not already, although if you're here, you likely are. Get the announcements about presentations such as this and other chapter activities and general ASHRAE activities. And we'd be remiss if we didn't say thank you to our sponsors, one of which is CIM. In particular, I believe y'all have sponsored our mentorship program, so thank you all very much for that. And that's it for today. So thank you very much for attending, everyone, and thank you again, Paul, for the presentation.
Thank you, John, and thank you, everyone, for listening.
Yep. Take care.